Hey guys, we're back here with another video, and we're looking at understanding function notation. Okay, so function notation, this is, just so you know what we're talking about, this is when we're trying to understand problems that have this kind of symbolic appearance in a problem. So you'd see f parentheses x or g parentheses x. You'd use really any letter in front of the parentheses here, and what you're saying is you have a function of x. That's how we're going to say this, function of x. So this would be, again, a function of x. Even though it's a different letter, it's still a function of x. Okay, so the different letters, just so you know straight out, they're used when we're talking about multiple functions within a problem. Like, let's say we're comparing two things, or let's say that the function focuses on a particular item. Let's say that g of x, that could be the growth rate of a dog, hence g. F could be the number of feathers in a pillow. I don't know, but the letters here could be really anything. It's just a function of x. So what is a function? So we have to first think about that. A function is this machine. It is something where you put something into it. The function works with that number, and it spits out a result. Okay. The closest thing I think of, like maybe you guys would understand it too, is, you know, there's machines where you put like a penny in and you turn the crank and it flattens the penny and puts this nice little picture on the penny. Like amusement parks have this. Maybe you have no clue what I'm talking about. But that kind of machine where you put something into it, the function manipulates it and spits out a result. So we put in a value, we put in a number into a function. The function, we have multiplication, we have division, we have addition, we have subtraction, we have exponents, and a whole bunch of other stuff. Okay? So what that does, after the function manipulates the number, it provides us with the result, or the output. I should say over here, this is going to be our input. So understanding input, output, that makes sense that you put in something and you get out something. So when in this notation, when we see a number on the inside of the parentheses, this is the input. This is the number that they want us to place into the function, and what we get as a result after manipulating that number, that is our output. Okay? Relating to like a coordinate plane, this would be our x coordinate, this would be our y coordinate. So let's actually look at some examples. I have three functions for us to focus on. So we have f of x equals 2x minus 3, and g of x equals 4x squared, and m of x equals the absolute value of x. Now, we're using three functions here, hence why we cannot just say y equals this, and y equals this. The functions, the different letters allow us to focus. When I say f of x, I'm focusing on this one. When I say m of x, I'm focusing on this one. So we see this, f parentheses 5. So f of 5. This 5, with this notation, this is our desired input. Okay? So we are going to place this into our function. Our function here is 2x minus 3. We're going to place it into that function, meaning where there's an x, that's kind of where the number gets placed in. So we have 2 times now 5 and minus 3. All right, so manipulating this, the function goes through 2 times 5, which is 10. Subtract 3, we get 7. So we would say f parentheses 5, or f of 5, equals 7. And that is our answer. All right? So let's look at another. So say we have g of negative 3. So I focus on the g function, and I'm inputting negative 3, and we desire the result. So we place the negative 3 into the function where our x is placed. You can often think of the x here as kind of there's a little hole where that's where the number goes. So you would have 4 times negative 3 and then squared. And then now the function is going to manipulate that number. So we have negative 3 times negative 3 is 9. And 4 times negative 3 is 36. So we would say here that g of negative 3 equals 36. So the function manipulates the number and it provides us with the result. So let's look at the last one. So m of negative 5. So here, negative 5 is our input. We are putting negative 5 into the function. A common mistake people make is that they put negative 5 on the left side and they try to solve for x. That's a very common mistake that I see. Also, I see people trying to put negative 5 into this x as well, and then they're trying to divide by negative 5 to both sides. Here, people put negative 3 into the left side and they're trying to divide by negative 3. This left side is simply a name. These are names. So here we're saying with the m function, okay, with the m function, place negative 5 into it. So we would have the absolute value of negative 5. And with absolute values, it takes the input, whatever it is, and turns it positive. So we would have m of negative 5 equals positive 5. Okay? So that's when we have the input, we place it into the function, let the function manipulate it, and it provides us with the result. So let's look at the next example. So we're still using the same functions here, same 3 functions, but this time I've altered the question. Maybe you can look at it for a moment. What is different? What is different about this example and the previous? Some don't recognize it. The difference here is that with the notation given, yes, it's written differently. The input is not 10. Many see this and just want to put 10 into x and solve it like you would the other one. So this is not f of 10, okay? No. This is not g of 80. No. And this is not the same as m of negative 18, okay? So no. So what this means is that we have the output and we desire the input. So you know how I said some students want to place a number on the left side and then solve for x? Here we do that. So what you can do really, you could put 10 equals 2x minus 3, but I recommend to replace this f of x with f of x. I'm going to substitute it down here. So I'm going to take this and write it just as, write what it is, 2x minus 3 equals 10. Now we solve for x. So we add 3 to both sides to give us 13. We divide by 2 to get us 13 halves, or 6.5. So writing our answer, we're saying when we input 6.5, our result is 10. Okay? Let's look at another. Let's say g of x equals 80. So again, we have our output. What is the input? What do we need to place into it to get that? So I'm going to replace g of x with what it is. 4x squared equals 80. So we divide by 4, giving us 20. And when we take the square root of this, okay, 20 is not a perfect square, so we're going to get a decimal, but we have to remember when square rooting that we get 2 results, guys. This doesn't happen every single time, meaning we do not have to square root every time, but when we square root, we have a positive and negative. Okay, so when we square root, we have positive and negative. We have 2 answers. So in our calculator, we can easily type in what is the square root of 20, and with that, you get a value of approximately positive 4.46 4.721, and then the negative would be negative 4.4721. And these are the two results. So with these two results, we get an output of 80 with the g of x function. It's important to understand that that's the g of x function, so it's going to be different with the others. So the last one, use a different color to add contrast. So m of x equals negative 18. So we're going to take our m of x function, absolute value of x, equals negative 18. And you think of this, that's not even possible, is it? Because the absolute value makes every input positive, so how can you get a negative value from it? Therefore, this is not possible. It is not possible to have an input that gives us negative 18. All right, so to close up here, I want to have you guys try these set of examples again, using the same three functions as above. So let's say we have f of, let's say, negative 2. Okay, let's say f of x equals negative 2. Let's imagine we have for a moment here g of 5. And let's say that we have here h, there's no h, oh my goodness, m of x equals 1 out of 10. Okay, so take a moment to try these out, noticing when you have an input and when you do not have the input and how the two problems vary. Best of luck to you practicing this more and more. Get these two problems done, guys, and I will see you in the next video.